Yep, it appears it does. All right. Well, thanks everybody for joining today. We have Tom Costello from Argonne National Lab, who's going to be talking a little bit about his experiences on running perfsonar on Raspberry Pis, but also in using Docker containers to do so. So Tom's been working on this project for a couple of months, I think. We started talking about this back in the fall, and he has some interesting results to show. And he has asked that we hold the questions until the end, but certainly if you do think of them and type them into the chat room, we'll answer them when we get to that stage. So Tom, I'll throw it over to you.
Excellent. Thanks so much, Jason. Hi, everyone. My name is Tom Costello. I'm with Argonne National Laboratory, and I'm a senior network engineer on the Business Information Services Division network team, which is really cool because we get to go to all different places all around the campus to help out with various network connectivity issues. And of course, today I'm here to talk about campus network monitoring using perfsonar on Raspberry Pi single board computers and inside of Cisco NX-OS using Docker containers. So this very first screenshot that I have on the initial slide is kind of fast forwarding to the finished product, which is a Cisco 9000 Nexus 9000 series switch. And we can see that it has a management VRF IPv6 address, and then I can use that run bash command to show that there is a Docker container running perfsonar with the P scheduler stats on it right there. So before I dive into the slide deck and how we got to that finished product, I thought it makes some sense to explain how I kind of got into running perfsonar on some of this unorthodox, for lack of a better term, equipment. And this started 2 summers ago when I first started at Argonne. And within a couple weeks, I had a ticket that involved troubleshooting some packet loss between one of the scientific data centers and the rest of our campus network. And it was a really quirky issue. It kept on happening only at like 8 p.m. every night. And I thought, oh, man, you know, I previously worked in the financial services field, and we had this very niche but very robust set of end-to-end network monitoring tools that was very specific to financial services. I thought, oh, I wish I had toolage like that to see this on the campus network. And then I read a little bit more about perfsonar, and I was super excited to find out that perfsonar is effectively the equivalent of that in the research and education field. And having the ability to do the MADDASH dashboard like we see in this, this is a slide that was given a couple of years ago by Andy Lake at a similar ESNet presentation. And being able to have that gigantic number of green boxes telling you that there's no packet loss and being able to kind of spot some of those needles in the haystack before you have someone calling to complain about network performance issues. I thought, wow, that'd be so great if we could do that throughout the campus. And then I found out that it could run on a Raspberry Pi, and you're talking about, you know, less than $100 US, give or take, once you get all the bells and whistles on it to run one of these inside of a campus building. So I talked with my team lead about it and just asked what would be the likelihood of us being able to do this in the campus. And he got back to me saying, well, let's do a test bed POC first. Let's see, you know, best case scenario, maybe this is something we can use on the campus. Worst case scenario, you'll learn a whole bunch about perfsonar, and either way, that's a win-win. So as with anything in network operations, I put that on the to-do list. And then more interesting things got to the top of the to-do list. There were just bigger fires to fight. And so quite some time passed between the first packet loss ticket. And I think this was actually in November of 2020. There was a blog post on Light Bytes at ESNet, and they actually used one of the perfsonar nodes that my team, the BIS network infrastructure team, manages as one of the nodes that was having packet loss issues. And so this was actually a really good read and a good wake up call for me that, you know, Tom, I should probably get this on my to-do list a little bit higher. One, just because I found perfsonar to be super interesting, and two, trying to get to the bottom of some of these packet loss issues. And at first I thought, well, maybe let's wait until after we do a deployment of this stuff in the campus before I start doing any type of talk like we have today about it. But then I saw the email from Jason about, you know, looking for some of the talk topics. And then I thought we easily have a good 40 minutes worth of content with all the lessons learned from doing this POC testbed. So here we are today. So we'll start off with a quick slide about some of the learning objectives. Again, this is a lunch and learn, so I figured just to quickly summarize some of the things that we'll be learning about today. At the very top, kind of a prereq before we get too into running a campus network of perfsonar nodes, whether it's Raspberry Pis, NX-OS containers, or just plain old perfsonar-toolkit ISOs, either on bare metal or VMs. When you're doing this throughout a campus, you're really going to want to have that central MADDASH dashboard. It just looks really nice. It gives you a big value add, being able to see everything with all of those green check boxes. And the even bigger value add is with PS config. You can just have one central config to rule them all. You don't have to go to every single node in your campus and do a handcrafted artisan config. You really want to have just one config that you can push everywhere and not have to deal with that manual labor setting up all the tests between all the different nodes. Next, we'll talk about running perfsonar-toolkit, and that's actually not a typo. It is perfsonar-toolkit, not perfsonar-testpoint on a Raspberry Pi 4. It can be done for campus monitoring use cases. Again, just because you can run perfsonar-toolkit on a Raspberry Pi 4 doesn't mean you should. You'll probably be better off with perfsonar-testpoint instead of toolkit. I'll talk quite a bit about that later on. And then running the perfsonar-testpoint container on a Cisco NX-OS switch, as long as it's running NX-OS version 9.2.1 or above. That's pretty fun and easy to do. And then all the lessons learned from doing this inside of our networking team testbed. And lastly, I'll finish up with some use case ideas, just kind of spitballing some ideas that you might be able to take home to your home institution if you decide to try any of this at home. Now, throughout the talk, there's a recurring theme that I come from a pretty strong network engineering background. I'm really big on things like router configs, switches, firewalls, tying the data center together, things like that. I know enough Linux system administration and systems engineering to get by. It's not my strong suite, but I'm decent with it. And then I'm super weak when it comes to software engineering. Before doing this PS config exercise, which is editing a JSON file, it had been quite some time since I touched JSON last, and that's fine. We all have our strengths and weaknesses, and there's a couple tools I use to make up for some of those weaknesses that I'll be talking about that hopefully you'll find helpful. And then lastly, as everyone knows nowadays, the supply chain crisis is hitting everyone and everything, and that includes Raspberry Pis. It's actually quite difficult to get some of the Raspberry Pi 4 models nowadays, but you can run perfsonar-testpoint on a Raspberry Pi 3B. I just tried that earlier this week just for the sake of knowing, and it does work. So even though the talk is focused on Raspberry Pi 4, the results are Raspberry Pi 4. Just keep in mind there are other options. There's even other vendors of single board ARM-based computer that you could do very similar things with here. Okay, so target audience, again, everyone is welcome to attend this talk. I like reaching the largest audience possible about perfsonar, but I tried to kind of narrow down the scope of this talk specifically for the people that fall into these categories of those that are looking to improve end-to-end network monitoring in a campus using low-cost perfsonar hardware. I think that's the true target audience that we're looking at here. And then if you have network gear with Docker support, such as these Cisco NX-OS switches, the reason I'm doing Cisco NX-OS is we just had one of these switches laying in our test bed. So figured, well, that'd be pretty neat to get perfsonar containers running on it. But there's other vendors where you can certainly do the same thing too. If you'd like to run these perfsonar containers on the network gear, this talk will be highly applicable. If you know what Raspberry Pis and Docker containers are, that'll make the talk even more easier to digest. And then lastly, having some knowledge of perfsonar or even a similar end-to-end network monitoring tool would definitely help a lot of this stuff resonate better with whoever's listening. Now, if you're not in any of these target audiences, that is perfectly fine as well. I just wanted to share a couple resources that I found helpful when I was starting my perfsonar journey a couple years ago. And the first one is the perfsonar project has a really good YouTube channel. I'm pretty sure that slide I had earlier is from one of those presentations on that YouTube channel. Lots of really good hands-on stuff over there. Docs.perfsonar.net. The documentation is just superb for the entire perfsonar project. Big thanks to everyone that's had a hand in that. And if you've never done anything with Raspberry Pis before, Raspberry Pi Foundation has entire curriculums about using these things. There's just tons of stuff out for free in the public domain to learn about those sort of things if you're interested. And then lastly, I put this book here. It's called Containers in Cisco iOS XE, XR, and NX-OS. And so again, with the recurring theme of I'm more of a network guy. I'm not too big on systems, and I'm not really that into software engineering at all. And so I felt like I almost had to do a little bit of catch up at first, understanding what Docker is, kind of figuring out with container networking and Kubernetes and all of these other terms that I've heard on podcasts, I've heard from talking to coworkers, but I just wasn't too sure myself about what some of that stuff was and how to explain it. And the thing I really liked about this book is that it's really hitting that target audience of network engineers. If you or someone is in network ops, is a network engineer, but doesn't really have any day-to-day interaction with Docker containers or anything like that, the introduction of this book, the first couple chapters, just really explained it better than anything else I've been able to see. Just because, in my opinion, it seems like a lot of the container and Docker training out there is really written for those trying to do more of the systems engineering and software engineering type things, not so much on the network side. So again, just wanted to put that out there. If you are like me, where you're more of the strong suites in network engineering, this book might help quite a bit. If you already have experience with Docker, or if you're more on the systems or software side, you can probably give this book a pass. But just wanted to make sure if you're not in the target audience, don't worry. This talk is still hopefully going to be applicable. Maybe some of this will help you get more out of it. Okay, so kind of going back to what I started with is that everything we're talking about today is based off of the campus network monitoring test bed that we built at Argonne inside of the BIS networking team's test bed. And so the way this looks is we have our core switches, and then we have a test bed switch, just really dirt simple layer 2 power over Ethernet switch. The layer 2 power over Ethernet matters because the Raspberry Pi is actually being powered over Ethernet. It's only consuming about 15 watts of power. And so that's our PSONAR-RPI4 over here in the corner. And then we have the Cisco NX-OS switch, in this case, a 93180YC that's running that perfsonar-testpoint container on the right side. Now, again, I'm a network guy. We're on a network test bed. We typically don't have hypervisors just hanging out in the test bed for us to play with, but we did have some EVE-NG Community Edition network simulators where I do have the capability of running VMs and all types of different switch images and things like that. So what I ended up doing for our environment is we just simply built out a whole bunch of CentOS 7 VMs, 4 running perfsonar-toolkit just to get kind of a control group for just regular old x86 perfsonar boxes, and then 1 VM running perfsonar-centralmanagement. Again, just because we didn't want to hand do all the configs for all of these boxes. We want to have that centrally managed, and of course, get that really nice looking MADDASH dashboard to have all the results be pretty as well. So with that, let's get started on the perfsonar central management setup for this test bed. So I'm going to go through this pretty quickly just because there's far better resources out there, YouTube videos and this guide that I believe Andy Lake had quite a bit to do with. It's kind of the quick install of MADDASH that just walks you through installing CentOS. In my example, I put our ESNet neighbors next door, Fermilab. They have a Linux mirror open to the public that has a CentOS 7.9 ISO. Following that document, that quick install guide, it actually took me a while to find this. At first, I was using an obsolete guide. Nothing worked. I couldn't figure out why. I think I found the link to this on the perfsonar user mailing list, and this guide is amazing. It just walks you through doing the basics to get that dashboard set up and going through the perfsonar central management install. Really good stuff there. And another really interesting thing I found, I haven't done this myself, but it turns out Phil Reese has this really great code repo up on Stanford's GitLab where he has an entire infrastructure as code set up with Vagrant and Ansible to build out a perfsonar sampler, actually pretty similar to the topology that you see here with the VMs and the central management. Very similar design, just done in Vagrant and Ansible, where you just download that code, you have Vagrant do its thing, and it just works on a workstation, assuming you have enough cores and CPU, CPU, RAM, etc., to actually pull that off. Definitely something to take a look at if you plan on trying any of this at home. Now, the next big thing is with psconfig, you have a central JSON file that goes out to all the perfsonar nodes so that they know all the details about the tests that they're going to run, et cetera. And so again, I'm a network engineer. I am absolutely not a software engineer. I'm not the best when it comes to JSON. And when I first started messing around with this skeleton.json file to try to get all my perfsonar nodes to run tests against each other, I was just hitting issues left and right where my JSON was sloppy, it would error out, things wouldn't work. And so one thing that I wish I did earlier on in the testing process would be using a newer IDE. In this case, this is VS Code that supports bracket pair colorization and JSON issue detection, so that if you're like me, where you don't really do JSON very often, it makes it much easier to detect silly mistakes, of which there's many in the screenshot. Apologies to all the software engineers out there, where I'm sure this screen is probably burning their eyes. But so at the top here, so we can see with the JSON error detection in VS Code, it's saying that I missed a comma on line 20. We can see it's actually on line 19. We missed the comma there. I'm missing a curly brace at line 12. We can see that because the coloring doesn't match up. And it looks like I have a duplicate object key. So just a lot of stuff that would otherwise take someone quite some time to debug, you get, right in front of your own eyes inside of these IDEs, which I really enjoyed. This tool really helped me make up for some of the lack of JSON experience I had. But one other really big typo in this that I still left in on purpose is on line 11. So when we're using IPv6 addresses, and again, I made all of these IPv6 addresses just for instructional purposes only. Normally, this would probably be a DNS record. But so this URL to my perfsonar central management server, so I put the brackets in the entire URL, where it really should be this this top bracket should be right after the 2 slashes for HTTPS. So this wouldn't work. This would bomb out if you tried to add this using the PS config agent. So the point I wanted to make here is that even with all the fancy new tools that you have with JSON error detection, it's still very easy to have some human error. In this case, with the IPv6, the brackets around the address for the URL going to that config file. So just something to keep in mind that I know I spent quite a few hours troubleshooting a lot of tiny issues that would have been pointed out much faster had I been using an IDE earlier on in the process. So once you get all of your JSON config straightened out and the perfsonar central management package gets installed on the Linux server of your choosing, you should be presented with something very similar to this when you go to the web GUI for MADDASH, where we can see that all of our nodes in the matrix down here, they're all orange because there's no test data yet. And that's exactly what we're expecting. So we will have test data in a little bit. But again, I would highly recommend before doing any type of campus network monitoring test bed to have everything squared away with perfsonar central management. It will just make your life easier in the long run. Okay, so now that we've gotten through the initial PS config parts and the initial MADDASH setup, now we can talk about installing perfsonar-toolkit on the Raspberry Pi 4. So if you've never done much with a Raspberry Pi before, typically you'll use the Raspberry Pi Foundation's imager utility to load up on a micro SD card the OS of your choosing. In this case, I'm using Ubuntu 18.04 since that's within the compatibility list of perfsonar. You'll want to follow the first couple steps from docs.perfsonar.net to get the install going, just pretty much pointing it to the perfsonar Internet 2 repos. And then after you get that, if you've done the perfsonar-toolkit ISO install with everything prepackaged in CentOS 7 before, you might remember that one of the first things it has you do is define the username and password for the web GUI. You'll just want to kick off this Python script here that will do that for you after everything's installed. And then lastly, you want to have psconfig pull that testbed JSON file that you created so that we can have all of the tests loaded up without the manual labor. Now, a big thing that I screwed this up on multiple occasions, and I made sure to put this in bold, is that the configure archives flag needs to be set. Otherwise, everything will run, your tests will go through, but they won't make its way back into that MADDASH setup. So just something to keep in mind there if you're newer to psconfig and trying to get that working with the central management server. And one extra tip, I always seem to lose track of where all of my USB to micro SD card converters are. But if you or someone you know has one of the newer Dell Latitude 7400s, like those are kind of the standard end user laptops nowadays, that a lot of organizations like to mass deploy. Those actually have a micro SD card slot hidden in the side of them. And the new MacBook Pros as well have a standard SD card slot. But if you bought the SD card to micro SD card converter as part of that purchase for a micro SD card, just one less thing that you can lose trying to get this done on a laptop nowadays. And so once you get perfsonar installed onto the Raspberry Pi 4, again, assuming you went with perfsonar-toolkit, you'll actually get this, again, the perfsonar-toolkit comes with a really nice web GUI where you can see it has the built-in measurement archive. So you see your test results. You can even use this GUI to create tests if you wanted to. But again, I would actually recommend not installing perfsonar-toolkit unless you really want that full toolkit experience. It would make a lot more sense to install perfsonar-testpoint just because that doesn't have all the resources of the web GUI and the management archive, even though you can run all of that on a Raspberry Pi 4. And I wanted to do it just to see if I could or not. Doesn't mean you should do that. You really want to have every ounce of compute power available on these small, cheap single board computers to actually run your perfsonar throughput tests. So again, highly recommend running perfsonar-toolkit if possible if you're trying this at home. Or I'm sorry, perfsonar-testpoint if you're trying this at home. Okay, so now speaking of perfsonar-testpoint, we'll talk about running the perfsonar-testpoint container on a Cisco NX-OS switch. So in order to do this, you're going to need to be running NX-OS version 9.2.1 or above. That's just the first version that has all this container support. So keep that in mind. If you might have a switch that's capable of doing this, but you'll have to have a service impacting NX-OS upgrade before you might be able to do so. Now, another thing that I learned very quickly, this actually resulted in me having to do an unscheduled trip back onto the Argonne campus once, is that by default, NX-OS is going to put the container into the management VRF. So if you don't have that management 0 interface that's typically on the rear of the switch, plugged into your testbed network. There's ways around it, but the way that it was designed to just work out of the box, everything's going into that management VRF. And so for all my testing, again, I'm just focused on, for campus network monitoring purposes, doing this on gigabit ports. And so the management VRF was perfectly fine for my use case. But, and again, I'm a network guy. I don't really know a whole ton when it gets into the system side of var run NNS and some of the other things happening behind the scenes in Linux. But just keep in mind that your results may vary if you're using any of the other VRFs on the Nexus switches. Again, I didn't really go too far down the path of using things other than the management VRF, but there's certainly more optimizations you could do there. Lastly, the following minimum config would be required on NX-OS just to get out to Docker Hub and be able to download that perfsonar-testpoint Docker container. So again, just keep in mind that you need to both define the DNS name server and do IP domain lookup. Otherwise, it's not going to be able to resolve the addresses to get out to Docker Hub. Okay, so once you got all those initial dependencies figured out, this slide here, I am positive this will be burning the eyeballs of a lot of systems engineers since I'm doing this run bash sudo su-dash to get a root shell on the switch. Now, there's probably a more secure way to do this. Again, just for the sake of getting this working in the test bed, this worked and was able to get me, was able to hit the ground running with this, but I'm sure there's probably better, more secure ways to do most of the things in this slide. And once you get that root shell, you can go ahead and do service docker start, start up Docker services on the switch, and then you can go ahead and launch the perfsonar-testpoint container using this command here, docker run, etc. And in bold at the very end here, you really want to make sure that you add this /user/sbin/init at the end. Again, I'm not a systems guy. I can't fully explain why this is, but if you don't get that in there, all of the perfsonar, the container will install fine. You'll be able to get into it. Everything will look okay, but the perfsonar services won't actually start without that. It's something to do with systemd. And again, apologies. That's not really my my area of expertise, but very important to make sure you get that right. Otherwise, it'll look like it installed. It'll look like it'll work, but it actually won't. So once you get all of that squared away, now you can do Docker PS inside that root shell of the switch to get the container's ID and actually get into the container CLI once you get that container ID so that you can run the same exact PS config remote add config to pull that perfsonar central manage from the perfsonar central management server, the config file, get that really nice JSON testbed thing that will do all the tests for you. You won't actually have to define any of the tests on the switch itself. Okay, so the end result here, very similar to the initial screenshot on slide number 1, where we can see this is very clearly a Cisco NX-OS switch. We can do our run bash sudo su-dash. We can execute the bash command using our container ID within Docker to get into the container CLI. And then we can do a ps config remote list to see that the URL going to that JSON file and configure archives is set properly on our perfsonar container running on the Nexus 9000 series switch. Okay, so we're finally completing the test bed and we go back to our MADDASH dashboard and we see that it's not all going to be sunshine and rainbows. We're going to have some yellow squares, there's going to be some green squares, and that's perfectly fine because again, in this test bed, I didn't spend any time optimizing the Raspberry Pi 4's NICs, you know, that there was no effort put into trying to get every ounce of performance out of both the Nexus 9000 container, the Raspberry Pis, and these VMs are running inside of an EVE-NG simulator. We're expecting to see some packet loss just because, again, it's a test bed where everything was kind of put together just for the sake of seeing if this could actually work or not. So if you do all of this at home and you see a whole bunch of yellow checkboxes here, don't worry. Again, it's a test bed. It's a Raspberry Pi. We're not running this on, you know, tens of thousands of dollars of server equipment with very, very nice switches. This is expected for the situation that I was building. And so before I get into more of the results, just to quickly review this testbed diagram here, the first set of results is going to be on this PSonar VM1 virtual machine running perfsonar-toolkit. Now, this next screenshot in the next slide is just, again, because it's perfsonar-toolkit, you get the full-blown GUI, you get the full-blown measurement archive running on the virtual machine. So I just pulled that up real fast. And what we are expecting to see here is really good throughput numbers from VM1 to VM0, just because those are within the same EVE-NG simulator. There's no gigabit bottleneck. That should be pretty smooth looking. We are expecting to see a gigabit bottleneck to the other perfsonar toolkits running on the other EVE-NG x86 box. And of course, with the Raspberry Pi and the Cisco Nexus switch all plugged in at 1 gig, we're hoping to see something close to the theoretical max of around, give or take, 950 megs a second on all of those results. And so if we look at with the source of PSonar VM1, again, running inside of the EVE-NG simulator, going to our Nexus 9K container, the Raspberry Pi 4, and these other kind of control group x86 VMs, we can see that the Nexus 9K switch comes well short of the 950-ish, give or take, that we're looking for in the throughput test. And that's fine. Again, I didn't spend any time trying to optimize the container or like going into the control plane policing or anything. If I spent quite a bit more time, I think there's a pretty good chance I can get that throughput number a little bit higher. But just right off the bat, seeing 815 megs a second going to a network switch running perfsonar, that's pretty cool to see. It's definitely not bad, but definitely not the really good full gig line rate that I was hoping to get. Now the Raspberry Pi 4, we're at 929 megs a second. So that's really good. That's actually pretty darn close to that theoretical max of 950-ish, give or take throughput. So that's really good to see. And then of course, as we were expecting, just having these two VMs between each other inside of EVE-NG, there's no gigabit bottleneck. So we go well above gigabit there. That looks good. And then going from VM1 to the other VMs on that other EVE-NG simulator, we can see that we're capped again pretty close to the theoretical max. That's what we're hoping to see. So that's good stuff there. And again, it's not going to be sunshine and rainbows in the MADDASH dashboard. We have tons of yellow just because we're well under the full 1 gig numbers, but we do have the green squares between the VMs that are talking to each other within EVE-NG, not hitting that bottleneck. So that was pretty fun to see. Now, when we source the tests from the Raspberry Pi 4, So when we're generating the throughput traffic from that single board computer, we can see in the results here to everything, the Nexus switch and all of our x86 kind of control group VMs, that we're coming nowhere close to gigabit line rate. These numbers are all well under that theoretical max, but we're pretty close though. It's definitely a lot better than previous generations of Raspberry Pi 4. You know, we're getting into the 700 and 800 megabits per second range, which is really great. But I think the big takeaway here is that you're not going to be replacing x86 bare metal servers with Raspberry Pis and expecting to be able to do the same exact throughput tests in perfsonar. They're not quite there yet. We'll see what the next generation of Raspberry Pi brings us, but it's very obvious from these results that we're not going to be able to see a lot of issues when you start pushing the limits of gigabit line rate, simply because the Raspberry Pi isn't capable of producing those numbers with its single board computer setup right now. One thing I'll mention, and I'll talk about this in a couple more slides, is that again, I was using the, it's called the Power over Ethernet hat for the Raspberry Pi. So it has a built-in fan and it pulls power from the switch, which is really nice, makes it easier if you were actually deploying this to a campus. Just one less thing to worry about, getting the USB power into these. But these throughput tests are going to generate quite a bit of heat off of the Raspberry Pi, even though you can run them without a heat sink or a fan or anything like that. You'll definitely want to have some cooling on the Pi. And we'll talk about that later, but it's entirely possible that if I had a better cooling setup on these Raspberry Pis, or if I was, really trying to tweak around and optimize every ounce of performance out of them, we might get some better throughput numbers. But just right off the box, this was what I was able to get. And also really cool, this all of these stats are from the built-in measurement archive on the Raspberry Pi using the toolkit GUI from the Raspberry Pi 2. So again, if we were using perfsonar-testpoint, might have gotten slightly better results just because there's less stuff running in the background, but pretty cool that you can do that on a single board computer that's going to cost you, again, give or take, less than $50 for the computer itself. Okay, so lessons learned from the test bed. For the central management setup, if you're doing anything like I just did, trying to run the VMs inside of EVE-NG, just be extra careful about duplicate MACs if you're extending layer 2 from your testbed network onto the EVE-NG host. They're not the best when it comes to having unique MACs for every single item that you're doing in the EVE-NG topology. So just something to keep in mind if you try that at home. One thing I really wish I would have done is using Ansible. The perfsonar playbooks are really neat. That would have really cut down on some of the human error I had when I was just trying to figure all this out for the first time. If we were to do a larger deployment, I would definitely be pushing to do that just to make everyone's life easier to mass deploy out. Whether it's Raspberry Pis or x86 servers or any type of perfsonar node, using that Ansible definitely would have made things a little bit less likely for me to fat finger. And lastly, when I first started really going down the path of using psconfig, I was convinced that I needed to do the psconfig web admin utility. It's a really, really slick tool. I want to spend more time with it, but I was surprised that I really didn't need that for getting my test bed with the campus network monitoring going. Just editing that built-in skeleton.json file that's mentioned in that MADDASH config guide, that'll likely get you off the ground a lot faster if you don't have any experience with psconfig, or if you're not the strongest with JSON like myself. Again, the web admin tool is really neat, but just editing that JSON file by hand, preferably with something that will point out any errors before you start getting too far down the rabbit hole, you can definitely get a lot done with that. With the Raspberry Pi 4, again, just because you can run the full-blown perfsonar-toolkit with the GUI doesn't mean you should. The perfsonar-testpoint is most likely the best fit on those things nowadays. Again, with the power over Ethernet hat, it includes the fan, and there's actually some cases out there that specifically have room for that fan and the power over Ethernet adapter thingy that hops onto it. So just something to keep in mind if you're building a bill of materials for doing this in the real world. And again, just because you can run these without a fan or a heat sink doesn't mean you should. It will get warm. It'll still work, but your performance will likely decline. At least I'd be willing to bet that. from all the things I've done with Raspberry Pis in my personal life. So if your budget allows, also consider throwing an extra USB NIC on these Pis if you're deploying them to a campus environment. If you're in a perfect world where you have all the switches are the same vendor and you can use solutions like EarSpan or RSpan, that's great to look at traffic. But if you're multi-vendor or if you're going between, different solutions, it's really easy to just fire up TCP dump on one of these Raspberry Pis, just throw everything into a file, and then you're only limited to the size of the micro SD card as to how much data you can collect remotely at a span from a building. So a nice little added bonus there. Another thing too is you can consider installing the full-blown GUI in Ubuntu 18.04. And of course, that's going to eat up a ton of system resources. But some neat things you can do with that, especially deployed out to a campus environment, is that if you have effectively an Ubuntu 18.04 box, wherever you're deploying this, now you have the built-in Wi-Fi radio, the Raspberry Pi at your disposal. So you can go ahead and troubleshoot wireless remotely. I know that's pretty nice, especially during the pandemic. And you can use tools like Time Is to double check the time sync on the Pi. Again, the big thing with these Raspberry Pis is I'm a big Raspberry Pi fan, but time sync can be really difficult on some of these Internet of Things type devices. And if you're in a testbed environment where you might be knowingly or unknowingly blocking the UDP NTP traffic to do something like NTP-P-Q to use NTP to check the time sync. Time is kind of an extra sanity check that I really like. It'll work over an HTTPS proxy if you're doing that. And it's just one extra thing to check on the time sync, because it is very, very easy to have issues with MADDASH that might not actually be MADDASH issues, but just time sync issues between your nodes. And lastly, the user base for Debian-based distros with Raspberry Pis and all these different ARM single board computers seems to be quite a bit higher than those of the Red Hat flavored distributions. So just to keep in mind, with perfSONAR right now, all of the ARM binaries are Debian only. So if you're a RHEL shop or if you're wanting to do more of the Red Hat flavored type things, you certainly can, but again, I'm a network guy. I really don't have much experience at all when it comes to the software and system side of how you would try to get all these, getting everything to work on ARM, on CentOS or Red Hat or Rocky, et cetera. It can be done, but again, it's definitely not my area of expertise. If you're trying to get these Raspberry Pis deployed quickly, you'll definitely want to be going with the Debian-based distro. Okay, so the NX-OS container lessons learned. Apologies for the really ugly link, but that page by Cisco was incredibly helpful in troubleshooting getting the container to run. If you just search for Cisco Nexus containers, that should be the very first result. And then there's a lot of things I'm not talking about today in regards to containers, mainly because, again, I'm a network guy. This is not my area of expertise, but things like container persistence, getting Docker to auto start both itself and the container with the switch, deep diving into control plane policing. There's so many things that all in their own right could be an hour-long talk that I'm kind of glancing over today. If you're doing the Docker container on an NX-OS switch in the real world, I would definitely be spending a lot more time on those topics. And also just keep in mind that as of today, the perfsonar-testpoint container for the ARM platform, there's no support for it. Just for fun, I thought it would be cool to see if I could get Ubuntu 20.04 running on the Raspberry Pi along with perfsonar. And I wanted to use the perfsonar-testpoint container for that. And we can see Docker will tell us immediately that, hey, this is a container for AMD 64. It's not going to run on ARM 64, but we'll see where things go. There's nothing preventing you from building your own container, but just something to keep in mind if you're trying to do that at home. Okay, so lastly, potential use cases for everything I just talked about. So with the Raspberry Pi 4, if you have a new building coming online and you just want to generate a whole bunch of throughput traffic, just to make sure that, let's say if you use a brand new SDN overlay, or you have a new switch vendor, or even a new switch model that you haven't had on the campus before, you want to make sure that a decent amount of traffic can work through it. Getting a whole bunch of Raspberry Pis throughout the building would be relatively cheap and easy to do with that centrally managed JSON file. you can go ahead and get some really good throughput numbers throughout the building and see what there is to see there. Another thing, here at Argonne, we have a campus hotel, and one thing I think would be really neat someday is put one of these in a telco closet with all the other switches in the hotel. And if we have something like, for example, Department of Energy Cyberforce competition, where you have a whole bunch of students that are doing a whole bunch of 4K Twitch streaming, or I don't even know nowadays, and we have reports of packet loss coming from the hotel, it'd be really easy to take a look at something like a MADDASH dashboard and see, compared to your baseline of, oh, there's an actual issue, or no, this is just a whole bunch of users doing a whole bunch of very heavy feeds, especially if there's like a VIP suite or something, being able to see that before the VIP calls and complains about your guest wireless network. Another pretty easy, nice one there. perfsonar plays really well with IPv6. So if you want to do that in your test bed, definitely do so. And if you don't have room for an x86 server, don't have the resources on a hypervisor, the Pi might be an option there for you. And of course, these Raspberry Pis, even though we can't get the full gigabit line rate, if you're at a remote site where the WAN is going to be nowhere close to that, but you still want to add that remote site into something like a MADDASH dashboard, this might be a good fit for that. A couple other ideas: if you don't have any power or cooling at a location, but you really want to get a perfsonar node in there, the Raspberry Pi, you're only looking at, again, give or take, depending on how you have everything going and what cooling you're using, it's going to be something like between 10 and 20 watts. So pretty easy to add that on, even if you're already maxed out for power or cooling. And lastly, if you're trying to run this at home, pretty cheap to both buy a Raspberry Pi and power it, compared to a bare metal x86 server running 24/7. So just a couple of things to keep in mind there. Oh, lastly, another kind of lesson learned on the Raspberry Pi 4. So you can't take a regular like phone charger type USB charger and get the Raspberry Pi going on it without having quite a bit of performance degradation. There's just not enough power in the 2.4 amp USB chargers to do that. Some of the beefier chargers will work, or if you're really on a budget and you don't want to spend money on cases or USB adapters or anything like that, consider some of the tablets out there that already have tablets, laptops, etc., with USB-C chargers. If, let's say, your end user support group just did a brand new deployment and they have all of these old chargers, those might be really good for use on a Raspberry Pi. You might be able to upcycle them that way. And again, with the actual physical case for the Raspberry Pi, there's so many options out there. I've seen everything from very elaborate, expensive cases to simply using a takeout food container with some holes punch in it. So there's definitely a lot of creativity you can do there, depending on your budget and your bill of materials. So for the NX-OS container use case ideas. So again, the main reason that I went down the path of getting perfsonar to run on our Cisco NX-OS 9000 switch was simply because we already had one in the test bed. I thought I would like to add more nodes to the campus monitoring test bed. This would be a pretty fun thing to do. But in all honesty, running a container that's capable of doing the throughput test amounts of traffic on a mission critical switch, that may or may not be a good idea depending on your environment. I know depending on who you ask, you always want to run the smallest amount of things that can possibly go wrong on a very, very busy, very important switch in your environment. So just keep in mind, if it's a more of a research environment, where if the switch goes down because you did something that was causing issues inside of NX-OS with the container, if it's a low risk situation, that might be fine. I do not think I would ever be running a perfsonar container on an NX-OS switch that was in a very important environment. It just, I don't know, it just didn't get the best vibes from that. But that being said, if you do have a switch that's already capable of deploying the perfsonar test point container in a difficult to reach location, again, very easy to get that container deployed out. Sometimes it can be very difficult to even access some of the spaces that some of these switches are installed at. Or if it's really hard to get approval for an additional device, but you already have the NX-OS device on hand, again, it's able to run this stuff. or if you have an unexplainable network issue and you just want something that can do a throughput test immediately on equipment you've already deployed. So the screenshot here is from a lab I did quite some time ago, where originally the source and destination were going through, I can't remember the switch vendor. I think it was either Arista, maybe it was a Cisco 9000V or something inside of EVE-NG. And we can see that the throughput numbers through that are pretty good, well over 3 gigs a second inside of that network simulator. And then a couple days later, I looked at the results again after making a whole bunch of changes, and we can see that we're not even breaking 1 megabit per second. And so I was really confused at first that how could the throughput number drop that quickly just from making what I thought were pretty minor changes in the topology. And it turns out that Juniper VMX, if you don't install the license right away, it's going to rate limit itself down to 1 megabit per second. And sure enough, between these two perfsonar VMs running in EVE-NG, there was a Juniper VMX switch. And we can see that it does a fantastic job of limiting that throughput to about the theoretical max of 1 megabit per second, which was really cool to see. And it all made perfect sense after the fact of why we were getting that result. But in the middle of troubleshooting why I was seeing that, it was quite interesting trying to figure out what could be causing that. And perfsonar was a quite nice tool to have for that particular use case. Okay, so before we do the Q&A, I just want to give a gigantic thanks to both ESNet and all my coworkers at Argonne. I know quite a few people that have either hopped on or have helped me get this talk approved. I greatly appreciate that. Thank you so much, everyone, for attending, and hopefully we can fill up the rest of the time with questions and answers. If there's something I can't answer, or if you want to reach me offline, just search for Tom Costello Argonne. I'm fairly easy to find. And with that, happy to answer whatever I can.
All right, Tom, thanks so much for going through that. The chat room has been very busy. Some people just chatting about Raspberry Pi supply chain issues, but there were a couple of questions sprinkled in there. So I'll go through and read them as I see them here. Mark had the first one. If you can do so without violating any NDAs, could you compare and contrast perfsonar and the tool set you were using in the financial sector?
Oh, I would love to so bad, but without having, I probably shouldn't in this talk, but I'll reach out offline.
Okay. Let's see. And then we had some discussion here about trying to get the Raspberry Pi single boards and how people are on waiting lists. Tim from Internet 2 was pointing out that as you were talking about the initial setup of your boards here, another approach is to put the password setup in the cloud setup user data file in the boot partition mounted under boot firmware. And he posted a little bit of an example of what his looks like there, if you want to go and look at that. Doug has the next question. How consistent are the Pi 4s during very close, less than 5 millisecond bandwidth testing? Are they always about 930 megabits per second, or is there significant variability?
That's a great question. So I don't have a good answer to that, but I'll have to boot them back up shortly and take a look at that. That's a really good point, because again, one of the issues that I've ran into, not so much for this particular test bed, but just running Raspberry Pis as a hobbyist, is that when they're warmed up, and again, the ARM core inside of that, just the way that the thermal impact of performance, if you don't have either a good fan or if you're just maxing out all 4 cores at once, that can certainly impact the test results. So I don't have a good answer for that today, but let me dig into that further. I might be able to provide more color on that soon.
Okay. And then there was a couple of comments about another older CI talk from the University of Michigan software interns, where they've developed a couple of new plugins, specifically one where it was checking SSID strength and things like that. So that actually may be a good use case for something like this, but those are going to be out with the 5.0 release of perfsonar later this year or next. I don't remember where it is on the roadmap. So that was just a comment from a couple of people. Mark Foster was also talking about using the Raspberry Pi 4s for an NTP server solution using PoE without the PoE hats and dynamic cooling, and he provided a link there. And Doug would like to know, have you considered just running the Raspberry Pi 4s as a latency only and using latency changes to infer network issues versus maxing out the processor during bandwidth tests?
Yeah, so I haven't done much when it comes to doing the latency testing portion of perfsonar's capabilities. Again, mostly just for the sake of doing this initial proof of concept. We were trying to find ways to better detect packet loss throughout our environment. Because it's a campus where, for the most part, everything is very close to each other. We didn't really go down the path of digging too deep into just doing the latency test on the Pis itself, but that would make a lot of sense, again, because you only have that one single gigabit interface on the single board computer. Even though you could add additional interfaces with the USB ports, all of those latency results, I would imagine, would be all over the place while the throughput tests are either running, but both when it's the destination of the throughput test and when it's producing the throughput test. I could see that definitely having a lot of variance, just because of how cheap some of that single board equipment is. Hopefully I answered that question. I know it's a little bit hard because I didn't really do much with the latency side of things, but definitely a good point there.
Okay, so that's all the current questions. If people do have any others, please type them in. I have a couple others that I jotted down here. So with respect to that last example that you were showing where you were being rate limited to about 1 megabit per second,
Mhm.
did the graphs actually show any hints about how it was doing that? Was it just sort of selectively dropping packets, or was it trying to like idle the packet processing? Did you get any insight from the data? Is I guess what I'm curious about.
Yeah, I did not, but that should be it's been quite some time since in that particular topology where I was getting those results with the 1 megabit rate limit. It would actually be very, very easy to reproduce that. I might actually do this myself. All you need to do is just get a copy of Juniper VMX. And again, as long as you just have it, the full bare bones, not even having anything configured, I believe it will do that rate limiting automatically. It's not until you add the license or the valuation that you'll start to exceed that megabit per second limit. So I would definitely want to redo that test again. I'm actually curious myself now that you mentioned that. But yeah, that was actually a very interesting test bed, just because we were trying to get more familiar with Juniper VMX, and everything looked like it was working. I was able to send pings. Everything seemed to be fine, but again, do anything with throughput, and we were very, very quickly hitting that rate limit. And it was very, very nice having the perfsonar toolkit to be able to see that with our own eyes and not just guess as to oh, is this an EVE-NG problem, is this something else. It was very obvious that the throughput numbers were definitely nowhere close to what we were expecting.
Yeah, and I guess one last thing that popped into my mind too as you were going through that, and I'm going to date myself here because I haven't really done a lot with containers or the VM instances on these switches for a number of years. But one of the very early ones we tested, it used to idle the VMs if it didn't think they were doing anything. And what would
Mm.
end up happening is that if it wasn't doing an active throughput test or something, of course, then it looked like it wasn't doing anything. But then it would be forced to sort of wake up. Uh, and then what would end up happening is that would be reflected in the results. Did you see any other sort of odd results when you had them running on the switches themselves that just weren't explainable? Weird sort of latency shifts or weird sort of bandwidth shifts?
Yeah, that's a great point. So inside of the test bed, I wasn't really running a whole lot of anything else through that Nexus 9000 series switch. So if it was a real production environment where if I had, real dynamic routing protocols running, if we had real traffic hitting the management plane and everything else that you would typically see on a switch in a real environment, I could absolutely see use cases where, again, I don't have much of a systems background at all when it comes to NX-OS and how the container resources are allocated versus the resources for the actual, meat and potatoes, dynamic routing protocols, things like that are running not in the container, but in NX-OS itself. And I would expect that could easily have a very interesting impact on some of those throughput test numbers. Unfortunately, With the testing I did, because I just had that absolute bare bones config in there, that wouldn't have been the case that any of the other traffic in the control point itself could be impacting, or I shouldn't say traffic, any of the resources that the control plane needs for the switch to do the layer 3 switching things that it's capable of. That was not occurring during these tests, but I'm actually, now that you mentioned that, I'm interested to see in what that would look like when you really log down the switch with a bunch of dynamic routing protocols or other things that eat up some computational resources, and seeing what that does to that throughput test number.
Okay. And then probably our last question here, Ken says, I see you were using IPv6, and of course, Alan Winnery thanks anybody that does that. Did you discover any differences with IPv4 versus v6 when you were looking at the data?
Yeah, great question. And one thing I should mention is that, so in the topology, the lab was dual stacked. So it was not v6 only, but because I didn't really use IPv6 at all, I'm sorry, I didn't really use IPv4 at all, other than just remotely SSHing in from an environment that didn't have IPv6 enabled at the time. I didn't really think that the IPv4 side was relevant, just because, again, I wanted to just kind of show that everything in this lab was done v6. As far as performance between the two, again, everything in this test bed, just for the sake of keeping it simple, I just made it v6 only between all these nodes. So I actually don't have any data one way or another to answer that, but I'm not opposed at all to rerunning some of these tests, but with v4 and all the configs versus v6 and all the configs, just to see. Hopefully that answers that question. I know, even though I don't have a good answer there, I definitely understand what he's saying, and that makes a lot of sense.
Okay. Well, that's it for the questions. I did pump your email address into the chat room there for people who do want to reach out and harass you via email. Thanks again for going through this. When you get a chance, send me the slides. I'll make sure that those get posted along with the video. And for anybody who's still listening, we're going to be on, I think, a 3-week break, 4-week break. Let me look here quickly. Yeah, we don't have another talk scheduled until the end of the month on the 25th. So that's your hint, all of you people who are listening, that if you are working on something, even if it's in progress work, shoot me an email and schedule yourself to give a talk, because we are in desperate need of talks. So thanks everybody for joining today. Hope everybody has a good weekend, and we'll talk to you in a couple weeks.
Great, thanks, Jason. Thanks, everyone.